So from today onwards, we are going to look into this Java. Okay. So as we know, to work with Selenium, we have to know a programming language, and that is going to be Java for us. Okay. So let's take a look at Java, and maybe we can also take a look at programming languages in general. Okay. All right. So why we need a programming language? Okay. So basically, we will be writing program so that we want to do something using computer. Okay. So we need to tell the machine, the computer to do something. And in order to give those instructions, we will be using the programming language. But whatever the programming languages that we use, we write those statements in English, right? So in computer science terminologies, we call those languages as, okay, let me increase the font, high level languages. Okay. Whatever the language you are aware of, C, C++, Java, Python, JS, JavaScript, TypeScript, whatever it is, they all are high level languages. Okay. Which are understandable for human beings. Okay. Computer doesn't understand these languages. Okay. So these languages, in the sense, these English statements, computer will not understand. Then what computer will understand is only one language, that is machine level language. Okay. And in this machine level language, there are only two characters, that is 0 and 1. Okay. Computer can understand only these two characters. So whatever the instruction we want to give to computer, we have to write those instructions using only these two characters. Just imagine how difficult it would be if I have to write my entire program using only these two characters. Okay. Just to write one letter, or let's say I want to write hello computer. Okay. I just want to print this statement. Each character, this H, E, L, each character would be represented using 8 such zeros and ones. Okay, we call them as bits. Okay, a single character is called as a bit. Okay, in order to represent one English alphabet, we would require 8 bits. Okay, this would constitute 1 byte. Right. So so maybe H would look something like this. Then follow it up with E. E would look something like this. Right. In order to just give instruction to computer, if I have to code whatever the instructions I want to give in machine level language, then probably we all will go mad. Right. Because if suppose instead of this one I mistakenly put 0, the whole sentence would change, right? In order to overcome this challenge, these high level programming languages were invented. That's how these programming languages started. But initially when computers they came into existence, or they were created and people started using them, all all the programs were written using this structure only. Okay. So these, these instructions, we call them as machine level instructions. Even today, computer will only understand these type of instructions. The only difference is we will be writing our programs in high level language, English statements, human understandable language, which will be converted into these set of instructions using a converter. And for machine level, I mean, for a computer system, these instructions will be fed as an input. Okay, so that is how the process will be happening in the background. So basically, this conversion is important here from high level language to low level language. I mean, this machine level language is also known as low level language. Okay, so basically, there has to be some component which will do this conversion. Whatever the instructions we are giving in high level languages, say Java, it has to be converted into a low level language. Only then computer will understand it and it will process it. This conversion plays an important role when it comes to Java. That is actually giving an added advantage in case of Java. Okay, so we'll take a look at what is that advantage. So in general, if anyone talks about Java, the main advantage of Java that they would tell is it is machine independent language. Okay, understanding this is very crucial. Okay, so we'll come to this one, but before that, let's take a brief history of Java. Okay, so Java is used, I mean, as I said in the first class, Java can be used in multiple, scenarios. It can be used to develop a mobile application. It can be used to develop a web application, desktop application, games, and many more things. Okay, the usage of Java is widespread, but we are not going to learn all of this. We are going to learn that component of Java which is required for Selenium. Okay, then who developed Java? The person is James Gosling, and he was working at Sun Microsystems company at the time when he developed Java. Okay, and I mean the development would have taken at least 5 to 10 years. He would have slowly built it, refined it, and then packaged it as an end product. That would have taken somewhere around 5 to 10 years, but it was officially launched in 1995 for usage of everyone. Okay, since 1995 till 2010, Java was owned by Sun Microsystems. But in 2010, this company, Sun Microsystems, was acquired by Oracle company. So till today, Java is maintained, or it is taken care by Oracle. In the sense, Oracle actually acquired the Sun Microsystems. So now we don't say Java is from Sun Microsystems. We say Oracle's Java. Okay. So this change happened in 2010. Okay. And now let us take a look at this component, why Java is machine independent language. Okay. So, but before that, let me walk you through some brief history of programming languages. Okay. Programming languages history. This is something, interesting and you people should be aware of. So, on a high level, these computers became, I mean, they were started using in a widespread manner after 1950s only. Okay, so until then, computers usage was very, very limited. So all the programming languages history would start only after 1950. Okay, so in that context, if you come here, so these are some of the very initial languages. Okay, most of these names you might have not heard at all. Okay, but when we were studying, we at least knew these some of these languages like Fortran, COBOL, Simula, right? So these are important because these initial languages became the foundation for next set of languages. Okay, and the next set of languages, they became the foundation for the current languages. We can say the programming languages of three generations. So what we are looking at here is the first generation. These languages were not a general purpose language. Say for example, now Java, if I talk about Java, I say they can be used to do anything, right? But these languages were not so. Let's say if this Fortran was mainly built to do some mathematical computations, that's all, numeric computations. If you ask the same Fortran language to do some other things, let's say you want to play a video, this programming languages is not capable of doing it. So all these languages were built in that context. For a specific purpose, they built it. Okay. Definitely, this is not a good thing because if you want to do mathematical calculation, you go with one language. If you want to do some video editing, then you have to go with another programming language. If you want to, do some text editing, you have to go with some other programming language. So this challenge was overcome by the next generation of programming languages. Okay. The second set of languages. I think by looking at these names, you might be aware of some of the names. Like there is something called as a C language. There is something called as Smalltalk. Right? There is something called as Pascal. So these languages actually solved that problem of the first generation of problem, wherein they were only targeted to do one operation. These languages, second set of languages, now they can do multiple operations. Okay. But the challenge or the problem with the second generation of programming languages is they are doing the job, but efficiency is nowhere in picture here. बस हमें काम हो जाना चाहिए. वो कितना टाइम लेगा, वो कितना रिसोर्सेस लेगा, people are not bothered about that aspect. Okay. Say for example, C language will do everything. What Java is currently doing, it can do everything. But the efficiency is much, much, much lower. So at this time period, people are not, looking into the efficiency. They were happy that these programming languages can do multiple things. They can achieve multiple things using a single programming language. That was a big shift. Okay. And these programming languages led to the next set of languages or next generation of languages, wherein doing multiple things was always there, but now the efficiency came into picture. How efficiently we can execute our programs, how compactly we can structure our programs. Considering those points in mind, the next set of programming languages came into picture. These ones. These must be, I know you must have definitely heard about these things. C++, MATLAB, Objective-C, Perl, all these things came into existence, which actually improved the efficiency from the second set of languages. Okay. So these are again, we can call them as modern languages, which are, some of these are still in use even today. And the next big shift happened in the 1990s when the internet came into picture. Just imagine, before 1990, there was no internet. Okay. All these programming languages, they were, I mean, if I want to write any programming language, I have to rely on a computer and I have to choose a language which is actually compatible with that particular machine. It was so machine centric. If I have a Windows machine, I have to install all the softwares, programming language that is compatible with that machine. If I have a Linux machine, I have to set my machine or install all the components that are compatible with only that machine. And let's say I have a Windows machine and I write a program. I can only run this program in only my machine. If I compile it, I mean, if I just put it in a file and give it to someone else who is having a different machine, it might also be a Windows machine, but the configuration will be different. That person would not be able to use the same program in his machine. So these programming languages and whatever the programs people were writing, that was so very machine centric. It was written for one machine. It has to be run on the same machine itself. If you want to do the same operation on another machine, you have to rewrite the program. That was a very big, shortcoming that was actually overcome with the, onset of this internet. When internet came into picture, it actually connected the whole world. I am sitting in India. My friend might be sitting in the European countries, and I can develop a program here. I can simply transfer my program to that person and he should be able to use it. Okay. So this added advantage was possible because of internet. This advantage led to the next set of programming languages to cater to this need, or rather, I would say, to take the advantage of this internet. A new type of languages came into picture. Those languages, we call them as object-oriented programming languages. Here, in this category, our Java will also come into picture. And if you observe, Java is in 1995. Okay. Before that, Python is already there. Ruby is also there. But these Python, these Ruby, they are gaining more importance in today's times because people have figured out some use case scenarios for these languages. In machine learning, in neural networking, in artificial intelligence, Python is more suitable to write the programs. That is why this Python has come to front, in today's scenario. But if you take a look at the history, these languages are ancestors to Java. Okay. And these languages are what we call as object-oriented languages. So whatever the languages were there before these object-oriented languages, we call them as procedural languages. Okay. Procedural languages is a technique of programming. Object-oriented paradigm is again a technique of programming. Okay. Now in today's world, every language that we are going to use, it will be a object-oriented programming. We are no more using any procedural languages because they are slow. You would have to write a lot of repetitive codes there, and all those extra effort would be required if you adopt any procedural language. So now people have completely stopped using any of these ancestral languages, which are procedural languages. Now they are only focusing on these languages, which are object-oriented language. Even in these object-oriented language, some of them are scripting languages, right? So what is the difference between a proper programming language and a scripting language? Scripting language is a lightweight language. You do not have to follow much of the syntax or rules there. You can, write a very vague program and still, you would be able to do your intended job there. Okay. You will understand it once you get familiar with any one programming language. So this is a brief history of programming languages, how they have evolved. Okay. And if you think of some of the days before 1970s, people largely used programming languages for a specific machine. Okay. But today, the scenario is completely different. Whenever I write my program, I'm not writing it for my machine. Rather, I'm writing it for the whole world. I write a program, it can be transferred to any part of the globe and it can be executed on any machine. I will write on Windows machine, someone else can run it on a Mac machine. Okay, someone else can run it on a Linux machine with a different configuration altogether. And this is possible because we have some features in these languages. Okay, so more or less all these programming languages are having those features, and Java is actually the front runner in adopting those features. Okay, and what is that feature? Machine independency. Okay, So this machine independency, it is nothing but I write program in one machine and I should be able to run it on any other machine. It can be a different platform, different operating system, different configuration also. So how Java is achieving this feature? This feature again, it brings us back to this, this concept: high level language, low level language, right? So it is difficult for us to understand this language. So it is easy for us to understand this language, which is an English language, right? So what I will do, I will write a program in a high level language now, in an English language. I will simply write something like this: public class first program. Okay. Public static void main args. Don't worry about these things. We will learn all these keywords here in some time. But this is how we will be writing a program in Java. Okay. And now I will write something like this: system.out.println hello Java. Okay. So basically what I want to do is I want to print this word or this statement in the console, in the output window. Okay. In order to print this much, I am writing this program. So this program is an instruction for my computer. You open the console and write these two words in the console, right? And if you observe these statements, these are English statements. I can easily understand them. So this style of writing, we call them as high level programming. Okay, this is Java. If you go for Python, if you go for JavaScript, it would all be, still the English statements. But this is not something which computer will understand, right? What computer will understand? It will only understand these things. So now we have to basically convert this high level language to a machine level language. And that machine level language will be executed by the computer. And that conversion process can happen in two ways. First one is compilation. Second one is interpretation. Okay. So these two types of conversion we can achieve. I mean, using these two types of conversion, we can convert any high level program to a low level program. Okay. Now, what is the difference between these two approaches? Compilation. Okay. So now we have 5 lines of statements here. 5 lines of code we have. This entire 5 lines will be converted at one shot. That type of conversion is compilation. Okay. The second type, interpretation. In that, what happens? Line by line conversion will happen. First, it will only pick the first line. It will convert it into a machine code. Next, it will pick the second line. It will again convert it into a machine code. Third line. Like this, if it is the conversion is happening line by line, then we call it as an interpretation. Rather, if you take this entire file or entire block at a time and do the conversion, it will just simply convert everything at one shot. This process is called as compilation. Okay. And if you take a look at these set of languages, some of them may be interpreted languages, some of them would be compiled languages. Okay. It actually doesn't make much of a difference for us. From the end user's standpoint, we just want to convert this. That's all. Whether it is compiled or interpreted, it is not of much importance for us. We are comfortable writing statements in English. We will write them. All that I want is someone has to convert this into this statement. Whether it is compiling, whether it is interpreting, I do not bother of it. Okay. So all these programming languages have adopted one or the other technique. Python may be interpreted, Java may be compiled, JavaScript may be interpreted, right? Now, when it comes to Java, it is actually doing both the techniques here. Okay, that is one extra feature that Java language is providing. So what it is doing, it will first compile this, okay, and it will not compile it into these statements. Rather, this conversion from high level language to machine level language will happen in two steps when it comes to Java. Okay, and this is why Java we say machine independence. It is achieving this machine independency because it has adopted some extra feature while this conversion. So how a Java program will be converted to a machine level language is first step. Okay, high level code. Okay, high level code will be compiled. Okay, high level code will be compiled, and what we will get is not machine level code. Instead, it will be an intermediate code. Okay, step two. This intermediate code will be interpreted, and what we will get? We will get machine level code. See how this Java people are doing the things is they are not doing the conversion in one shot. Okay, rather they have introduced one more step in between. And why they have introduced that one more step is, at the end of first step when you do the compilation you get an intermediate code, right? This intermediate code is machine independent. What it means is I have written this program. Okay, now once I compile this I will get an intermediate code. That code I can give it to anyone. Okay, and that person might be having a different configuration machine, but still he would be able to execute that code in his machine. This intermediate code is machine independent. And why that is happening? Because this intermediate code is getting generated for a theoretical machine. Okay, it might be a little confusing for you people, whatever I'm telling now, but eventually you people will get it. Okay? So this compilation process in the case of Java is targeted to a machine called as Java virtual machine. As the name itself is suggesting, it is a virtual machine. It is nowhere physically present. So what Java people are doing, they have conceptualized a machine, an imaginary machine, considering that this machine will have this feature. Okay, and no matter where you go in this world, this Java virtual machine configuration will be same. Okay, so considering this, the first step compilation will happen targeting this machine. Okay, so we did the compilation targeting this machine, and the end product of this conversion would be an intermediate code. Now I will give this code to someone else. Okay, now that person, in order to run this particular code, he has to do the second step, right? So this second step would be done by Java Development Kit. We simply call it as JDK. So what is this JDK? This is nothing but whatever Java installation we do, that is what is called as JDK. So the basic criteria here is any person who wants to execute a Java program, he has to have a Java installation. That's all. And once he has the Java installation, he can simply run this intermediate code. Okay. So now let us do this process. So I have written this particular program in high level language. Now let me do this conversion, first step of conversion. Okay, so what I will do is I will simply save this file. Okay, I will give the same name, first program dot Java. Okay, I saved this particular file. Now let me copy this and put it in a folder. Create a new folder, Java. I will put it here. This is my program. It contains these set of lines, these 5 lines it contains, right? So now what I will do is I will open a command prompt. So I'm using a Mac machine. So command prompt is a terminal in this machine. Okay, if you are doing the same process in a Windows machine, you would be opening a command prompt. That's all. Okay. So I open a command prompt from the location where that particular file is present. Okay. So now what I will do is I will simply write a command called as java c and I will give the file name first program.java. So what does this command mean is java c means Java compiler. So I'm calling the Java compiler and passing this file. So what is the purpose here? Java should compile this program and convert it into an intermediate code. Right. Now I will hit enter. Okay. So there are some, these are some errors in the program. Let's see. Okay. What is the error? Okay. System.out.println. Okay. Everything looks fine, but what is happening? Okay. All right. So here is the error. So I should write it outside of this args. I will save this. I will just copy this one more time and put it back here. Okay. I had done some typing mistake here. Now let me run it once again. Okay. So now the compilation happened. So now that intermediate code should be generated, right? Let us go and look at here. See, this is the intermediate code that I was talking about. If you look at the extension, this is first program.java and this intermediate code's extension is first program.class. Okay. Now this first program.class, this intermediate code, the compiled version of my program, I can ship it to any part of the world and any person will be able to execute it. Only requirement would be he should be having a Java installation on his machine. That's all. And why this is all this is happening because of this JDK. Okay. So anyone who wants to execute this program, they have to have this JDK. That's all. And Java people thought of this process and they brought in between a conceptual machine called as this Java virtual machine. Why I'm explaining this? Anything out of this could be asked in interview. Okay. How Java achieves machine independency? This might be a question, or they might simply ask, what is a Java virtual machine? So what is Java virtual machine? It is a theoretical machine or an imaginary machine considering which Java compiler will compile the intermediate code. What is the advantage of this? Once we get this intermediate code, we can transfer it to any other computer and that computer will be able to execute it provided that computer contains a Java development kit. Okay. And that is how Java is achieving machine independency. You do not have to worry about in which machine it is compiled. Rather, if you take a look at other programming languages, older languages, If I compile it on my machine, I can run it only on my machine. I will not be able to run it on any other machine. Okay. So now we will come back here. Now we did 50% of the task. It is still not in an executable form. I compiled this program and generated an intermediate program, but still I am not able to execute this. To execute this, I have to do this second step as well, interpretation. Okay, so let us do that one. For that, I will write this one. Okay. If you closely observe, the first command I wrote is Java C, Java compiler. The second command I am writing is Java, which means Java interpreter. So this is why Java uses both the techniques. First, it used the compilation technique. Entire program was converted to intermediate program in one shot. Now, this intermediate program will be converted line by line into machine code, and that code will be executed. If I hit enter, it will simply print whatever I wanted to print here. Ultimately, this is what I wanted. The purpose of writing this program was I wanted to print these words in the console. Okay, console is nothing but our output window. It can be anything. Now the output window is a command prompt. Output window can be a file if I want to write it on a file. It can be a monitor display if I want to display it somewhere. So in general, we call those things as console. Wherever we are outputting a program's result would be called as a console. Okay. So the purpose of this program was to print this two words on the console, and I am able to do that, right? But how it is happening? It is happening in two steps. First, compilation will take place. Next, interpretation will also take place. And because Java is doing this in two steps, Java is machine independent. Okay. All right. So this is a high level architecture of Java. Okay. Whenever we do the installation of Java, we will get this JDK, Java Development Kit. Whenever we run a program, this JRE comes into picture. What is JRE? Java Runtime Environment. What this Java Runtime Environment contains? It contains all those files and features that are required to run a program. That's all. Where is our Java virtual machine present? It is present within this Java runtime environment conceptually. Okay, that is not a physical entity. If you do an installation, you can actually go into your C program files folder and see this JDK folder. You can also see this JRE folder. You will not be able to see this JVM folder. Okay, it will not be there. It is just a conceptual thing, but that is doing the magic here. Okay, when it comes to Java. Similarly, if you take a look at Python or JavaScript, they would have achieved this machine independency in a different way. They would have not gone with this, virtual machine concept or intermediate code, doing the conversion in two steps. That might be a whole different approach in other programming languages. But Java is doing it in this way. Okay. Any doubts? Any questions so far? You guys are able to follow this much? Guys, any questions?
No, sir.
Okay. Okay. So the main thing what you guys have to understand is this process that we did. Okay. Because I don't think in your entire career going forward, you would do it in this way. Rather, you would be using any editor. Okay. Like Eclipse, like IntelliJ. Using these editors, you will write your program and you will simply run it. Okay. And all these two steps, whatever we did here, that will be taken care by that editor. Okay. We'll simply show now. what I will do is I mean this is an editor called as Eclipse. I will create a new project. Okay, it will be a Java project. Project name will be Java Learning. Okay. So under this, what I will do is I will create the same program. Okay. All right. So what it is asking me to do is let me first create a package. I mean, don't bother about all these things. You will slowly understand it. And the same statement I will again write here. Rather, I will simply copy. Okay. So the advantage of these editors would be this will provide us a place where we can write our program. And in order to run this, all that I have to do is I have to click on this run button. That's all. And you saw this output here. Hello Java. But in the background, those two steps are happening. First, it compiled this program, which created an intermediate file, dot class file, and that dot class file was interpreted, which then converted into a machine level code, which was actually executed, and that generated this statement in the console. This is the console of this editor now. Okay. So going forward, we will be doing, I mean, we will be writing all of our programs in this Eclipse itself. And how we wrote for the first time, we simply wrote it in a notepad, in a text editor. We saved it as a .java file, and using Java compiler and Java interpreter commands, we executed our program. But that is not how we will be doing going forward. Okay. So this brings us to the point wherein we will have to do the installations now. What installations we have to do? We have to do two installations. First thing is Java installation. Second thing is this editor installation Eclipse. Okay. So let us do the first part. Java download. Okay. So we all know Java is from Oracle. So we can go with this link. Okay. And here you can see the versions of Java. Okay. When Java was officially launched in 1995, the version was 1. In 1996 or 7, the version would have been 2. Similarly, it has evolved over a period of time, and the current latest and stable version is Java 24. We can go with the stable, I mean the latest version itself. We can install Java 24 itself on our machine. Okay. So how to install it? Just scroll down and here they are actually specifying the platforms. It can be Linux, it can be Mac OS, it can be Windows. Most of us would be using Windows. So you just come to this Windows section and click this second option. Okay. Which will actually download the installer, the exe file. Okay. Once you have this exe file, you just have to do do an installation like any other software. Double click on it. It will, start generating some prompts. Go on accepting them, next, 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 and finish. That's all. Okay. So I have already done this part. So let me stop this. Okay. Rather, actually, I have done this part, a Mac system. And one prerequisite for downloading these files would be you need to have an account in this Oracle. Okay. It will be a free account. You just have to create this account. That's all. You can use your personal Gmail as well. You can use your personal Gmail account, provide it here, and create an account first. Once you create the account, you have to sign in. Okay. Once you sign in, then probably will be able to download it. Otherwise, you might get a some error while downloading. Okay. So once you download this, all that you have to do is you have to run this executable file so that Java will be installed on your machine. Okay. And similarly, you can do for Eclipse as well. Okay. Eclipse download. And here we have a little bit of issue with the latest versions of Eclipse. Okay. So if you download these components, this is the latest version, 2025, 6th month. Okay. Don't go with these latest ones. So I would recommend you go with this version, 2024, 3rd month. Okay, that is what even I am using. And in the past, we have these experiences wherein this latest version of Eclipse and latest version of Java, they have some compatibility issue. Okay. So for Eclipse, what you have to do is you have to go with this particular version download. Okay. I will simply give this link in the WhatsApp group. All that you have guys have to do is come here and download as per your machine. If it is a Windows, you just select this one. If it is a Mac operating system, if it is an Intel chip, go for this one. If it is an Apple chip, go for this one. Okay. And you download this, and the next process is very similar. It downloads an executable file. You have to just install it. A plain simple installation. That's all. Okay. Once you guys are able to do these two installation, we have to set the environment variable for Java. Okay. So what this setting environment variable means is, let's say I downloaded this exe file for Java. I installed it. That installation would be in a particular folder under C drive program files. There would be a folder called as Java, right? I would be able to use Java only in that folder, right? If I want to run any Java programs, I have to go into that folder, write the Java programs inside that folder, then run it. That is a challenge, right? We would not be, doing the stuffs in that way. Rather, Java should be available in any part of my machine. It should be available on desktop. It should be available on D drive or E drive, anywhere, right? In order to make Java available globally on my machine, I have to set the environment variable for Java. Okay. Setting, let me say, Java environment variables in Windows 11. Okay. You just have to do certain steps here. Okay. This maybe we can do it in tomorrow's session. Okay. So maybe one of you guys can share your screen, and because I don't have a Windows machine. So in Mac machine, this environment setting is, we do it in a different way. In Windows machine, it will be in a different way. Okay. So, but essentially we are doing the same thing. We are making Java global in our machines. Okay. So once we make Java global in our machine, we would be able to write our Java programs in any place, and we will be able to execute our programs. Okay. So in Mac machine, we use something called as bash profile. Okay. Let me open it here. Okay. So if you guys are able to see this, so what I'm basically doing is, this is where Java is installed on my machine. I'm having Java 17 version, but that doesn't matter. Okay. You use 17, you use 20, 21, 24, it would still do its job. Okay. You guys go with the latest one. So what I mean by setting environment variable is, I will, basically set the path of my Java installation folder, and I will put it in a variable called as path. Path is a system variable. It would be present in all the computers. I need to give the path of Java installation in this path variable. That's all. Then what will happen if I write a Java program and run it? Our computer will come and look at this path variable. Under the path variable, it will try to find the location of Java. If we give the Java location here, then our computer will be able to utilize this Java installation. Right? This is the process of setting environment variables. We have to tell our computer where we have installed Java. That's all. Okay. So in a Mac machine, we do this in a file called as bash profile. Okay. In Windows, it is much simpler because you don't have to create a file like this and put this. You have some place in Windows machine wherein you can go and do this. Okay, you can follow any internet, website where it teaches how to do it. If you guys are able to do it, well and good. If not, in the next session, any one of you can share your screen, and I will tell you how to do this environment variables in a Windows machine. Okay. So by the next class, I would suggest you do both these installations. For Java, two steps. First, you create an account and sign in. It's a free account. Okay. You just have to have an account. That's all. Once you have this account, go and download the latest version. You have to just download this latest version and do the installation. Second thing, you have to download the Eclipse, a specific version. Don't go with the latest version as it is having some issues. Okay, as both of these are open source, we will be having these compatibility issues. So we have to basically stick to the versions that are working fine. Okay, so I will be giving this link in the WhatsApp group. You just open this link for Eclipse, download this, this particular version 2024 third month. Okay, and download this and install this one as well. Third thing would be setting the environment variable. You can just search in the internet how to set Java environment variable for a Windows machine and try to do it. If it works, fine. If it is not working, we will again do it in the next session. Okay.
Okay.
Okay. All right. So I think we can stop for today. Okay. And in the tomorrow session, we will, set all our machines ready. We will do this entire setup thing completed. And then we will start looking at this object-oriented concept. Okay. That is important because now going forward, we will be learning only Java. Till now, it is like, it's a very vague kind of a learning because we are touching upon multiple languages here, right? Now we will be focusing on only one language, and that is a pure object oriented language. So we will understand what this concept is. Okay, and then we will continue learning Java in a systematic manner. Okay. All right, any questions so far?
No, sir.
All right, all right. So
So,
let us
so
stop for today.
I just have
Yeah,
one doubt.
yeah.
Before this Eclipse thing, you just explained the concept of compilation and interpretation, right? So that
Mm-hmm.
knowledge we must know just for theoretical purpose.
Correct,
I mean, for interview question, that's it, right?
correct, correct.
Okay.
You
Okay.
would not be using it practically.
Okay.
You just have to be aware of it. You would be writing all your programs in this editor. That's all.
Okay.
And to execute this, you will simply run it. You will get the output. Okay, that is just
Thank
for
you.
understanding.
Okay.
All right, so let us stop for today. And by next class, you do all those installations. And if every installation is done, we will get started with Java. Okay. All right. Thank you.
Thank you.
Thank you.